Forget everything you know about time and space. The greatest scientific mystery isn't the edge of the universe. It's how you hear this sentence. Because the instant your brain creates a single, unified experience, your consciousness appears to break the speed of light. Stay with us to find out how, and why the ultimate speed limit of the universe is already too slow to explain you.
Welcome to the deep dive. Today we're doing something, well, a bit different. We're not looking outward at galaxies, but inward at maybe the biggest mystery there is.
That's right. We're talking about consciousness, the feeling of being you inside your head. And we're jumping straight into a conclusion that sounds absolutely wild.
Wild is putting it mildly. The basic idea we're exploring today, based on some pretty rigorous scientific arguments, is that your consciousness right now might be operating faster than light.
Yeah, FTL. It stems from a really fundamental problem that science struggles with, how you actually experience reality. Let's just take seeing, for example.
Okay, simple sight. Light comes into your eyes, gets processed, signals travel to the back of your brain, the visual cortex, basic stuff.
Right, but here's the catch. The info from your left visual field, everything to your left, goes to the right side of your brain.
And the stuff on the right goes to the left hemisphere. So these two streams of information land in physically separate places in your skull. We're talking about brain tissue separated by, actual distance.
Yeah.
If you stretched out the connections, it's thousands of miles of wiring.
Exactly. But when you look out at the world, you don't see two separate movies playing side by side that your brain frantically tries to glue together, do you?
No, never. It's just one seamless, unified picture, everything happening at the same time, instantaneous.
That instantaneous unity is the heart of the binding problem. How does information from physically separate locations become a single, simultaneous conscious experience? It happens too fast for signals traveling at light speed within the brain.
Okay, so this is where the FTL idea comes in.
Precisely. The radical thesis we're diving into today argues that for you, the conscious observer, to access and unify that separated information instantly, well, the observer itself must somehow operate faster than light.
So that sounds like it breaks physics. Like Einstein's #1 rule, right?
Yeah.
The cosmic speed limit.
You'd think so. But the argument here is fascinating. It suggests this FTL capability doesn't violate special relativity. There's supposedly a hidden loophole, a specific condition in Einstein's second postulate.
A loophole in Einstein's theory. Okay, you have my attention. What kind of loophole?
It hinges on what consciousness is. The conclusion reached in these sources is that consciousness isn't made of energy or matter. It's defined as non-energy information.
Non-energy information, so not a particle, not a wave, not located anywhere specific in space, just the pattern itself.
That's the idea. And if it's non-energy and non-spatial in that specific relativistic sense, then maybe, just maybe, the speed limit doesn't apply to it.
Wow. Okay, so our mission today is to unpack this, to show how neuroscientists apparently got cornered into this FTL conclusion.
Right. But before we can really appreciate this breakthrough, we need to understand why all the other explanations failed. We have to clear away the debris of old theories first.
Makes sense. You can't build something new without clearing the ground. So where do we start digging through the failed attempts?
Well, when faced with a problem like instantaneous binding across distance, the first place modern physics often looks is quantum mechanics, right? It's got all that spooky non-local stuff built in.
Yeah, things affecting each other instantly across space. Seems like a perfect fit for consciousness, connecting the two brain hemispheres.
It does seem appealing. But the specific quantum theories proposed for consciousness have run into some pretty serious roadblocks when you look at the actual evidence. We need to discard these first.
All right, so let's tackle the big one first. Quantum superposition. The idea that maybe the whole brain exists in this fuzzy, undecided quantum state, all possibilities at once, until consciousness kind of clicks it into place.
Sort of, yeah. A massive brain-wide superposition. It offers a potential way for separated parts to act as one unified whole. If everything's in one big quantum state, maybe distance doesn't matter internally.
Okay, sounds plausible. What's the problem?
The problem is stark, and it comes from the operating room, awake brain surgery.
Ah, right. So patients are awake, talking, while surgeons are physically interacting with their brain tissue.
Exactly. Now think about quantum mechanics. A superposition is incredibly fragile. If the brain were in this massive superposition, the moment a surgeon observes it, touches it, puts an electrode on it,
pop. The superposition should collapse. The wave function breaks down.
Right. And according to this theory, the collapse of the brain-wide quantum state should mean the patient instantly loses consciousness. plunged into darkness.
But they don't. They stay conscious, they report sensations, they follow commands. The observation doesn't crash the system.
It's decisive empirical evidence against the whole brain being one giant superposition. The consciousness persists despite direct physical observation and interaction.
Okay, that's pretty damning. Is there other evidence?
Oh yes, there's an incredibly rare and informative case.
Hmm.
The Hogan twins, Tatiana and Krista.
The craniopicus twins. Their skulls are fused, right?
And much more than that. Their brains are physically interconnected by something called a thalamic bridge. They share significant neural tissue, particularly in areas crucial for sensory relay and consciousness.
So if consciousness arises from a single brain-wide quantum state or even some kind of physical field permeating the tissue,
they should share one consciousness, one unified experience. They'd essentially be one person in two bodies perceiving through shared hardware.
But that's not what the studies show, is it?
Not at all. They have distinct personalities, different preferences, separate thoughts and feelings. One can sometimes experience what the other sees or tastes, but it's not a constant unified stream. They are demonstrably two separate conscious observers.
Two minds, despite the interwoven brains. That seems to kill the idea of a single macroscopic quantum state being the basis for their consciousness.
It strongly refutes it, yes.
Yeah.
Their separateness points to something else, creating the individual conscious experience.
Okay, so superposition across the whole brain is out. What about the other big quantum idea? Quantum entanglement. Spooky action at a distance. Could that link the left and right visual fields?
Entanglement is that weird connection where two particles are linked, right? Measure one, and you instantly know the state of the other, no matter how far apart.
Yeah, like they're coordinated.
The problem is, for entanglement to bind your visual fields, the information in those fields would need to be correlated in that specific quantum way, like perfectly matched or perfectly opposite.
But they're not. I can see, I don't know, a blue car on my left and a green tree on my right. The information is totally independent.
Exactly. One side doesn't dictate the other. Entanglement requires dependence. Our visual fields contain independent information streams. So entanglement just doesn't fit the bill for binding them together.
So the popular quantum explanations, they just don't hold up to scrutiny.
When you look closely at the requirements in the evidence, no. They seemed promising because of non-locality, but the specific mechanisms fail, which force scientists back to the drawing board, back to the physical brain itself.
Okay, so if quantum magic isn't the answer, maybe it's something more mundane. Like all the information just flows to one special spot in the brain. The convergence point myth.
That was the classical idea, yeah. The search for what philosophers call the Cartesian Theater, a central point, a specific location in the brain where all the sensory data arrives, gets processed, and consciousness watches the show.
The brain's command center. If consciousness is a physical thing located somewhere, this spot must exist, right?
Logically, yes. So neuroscientists embarked on this huge, decades-long quest. They called it the search for the unkillable consciousness.
Sounds dramatic. What were they looking for?
They were looking for that one tiny critical spot, a nucleus, a specific group of neurons, any small defined area that, if you damaged or destroyed it, would instantly switch off consciousness, like flipping a switch into a coma or a persistent vegetative state.
And they searched everywhere. Spinal cord, brainstem, cerebellum, the big cerebral cortex.
Everywhere, exhaustively, using lesion studies, looking at stroke patients, accident victims, surgical outcomes, and the result.
Let me guess. They didn't find it.
They found no single, small, localized area whose destruction reliably causes unconsciousness. None.
Wow. So there's no consciousness headquarters, no single point of failure.
Apparently not. You only get reliable loss of consciousness coma, vegetative states from large bilateral damage, meaning significant injury affecting networks on both sides of the brain. It takes widespread disruption.
What does that imply then, if it's not in one spot?
It implies the conscious observer isn't a tiny resident living at a single address in the brain.
Yeah.
It's somehow non-local, distributed, dependent on the integrated activity of vast networks, but not located within any single part of that network.
Okay, non-local, but let's just imagine for a second. Maybe the observer isn't stationary. Maybe it zips around the brain really fast, gathering all the info, even at the speed of light.
People considered that, but then you run smack into the speed limit problem.
The timing issue again.
Yeah, exactly. The numbers are just brutal. Your brain has something like 176,000 kilometers. That's over 100,000 miles of myelinated nerve fibers, the brain's internal wiring.
That's a lot of wire.
It is. Now, even if a hypothetical observer could travel along these pathways at the absolute Maximum speed possible, the speed of light.
It would still take time to cover that distance, right? To collect data from the far-flung regions, processing vision, sound, touch, and bind it all together.
Calculations show it would take at least 587 milliseconds, more than half a second.
Half a second. But my experience feels instant. My reactions are way faster than that. If it took half a second just to perceive something unified, the world would feel incredibly laggy and disjointed, like watching a badly dubbed movie.
Precisely. This inherent delay, known as the relativity of simultaneity problem at this scale, makes a light-speed traveling observer within the brain completely untenable. Our subjective experience of instant unity directly contradicts it. Locality sails on location and it fails on time.
Okay, so no single spot, and traveling around is too slow. Did they try other ideas, like maybe the information is broadcast somehow?
Yeah, that led to broadcast theories. Maybe the hemispheres don't send signals to a point, but they sort of radiate the information outward simultaneously, perhaps using electromagnetic fields or some kind of consciousness field generated by neural activity.
Like radio towers broadcasting the data for the observer to pick up?
Kind of. But these theories hit a major snag pretty quickly. The privacy problem? Think about it. If your brain is broadcasting its conscious information using physical fields or radiation strong enough to unify your own experience, why isn't that broadcast interfering with my brain when we're sitting here talking?
Oh, right. My consciousness field should be bleeding into yours and vice versa. We should be getting sensory crosstalk, maybe even merging experiences slightly, which definitely doesn't happen.
It never happens.
Yeah.
Our conscious experiences remain stubbornly private and separate, even in close proximity. And of course, who comes back to refute this idea definitively?
The Hogan twins.
The Hogan twins. If consciousness binding relied on broadcast fields, their physically connected brains, the ultimate test case for field proximity should absolutely guarantee a merged single consciousness. The fields would be inseparable.
But they have separate minds, so it can't be a physical field spreading out from the tissue.
Exactly. And there's one more piece of evidence that's just devastating. For any theory linking binding to physical proximity or distance, the hydrocephalus patient cases.
Hydrocephalus, that's where fluid builds up in the brain, right?
Yeah.
Creates pressure.
Yes, and in severe cases, it can drastically deform the brain. The ventricles expand massively, pushing the brain tissue outwards, stretching it thin against the skull. The physical distances between neurons and functional areas can become enormous, radically distorted compared to a typical brain.
Okay, so if binding depends on neurons being close, or on the strength of a field that drops off with distance.
These patients should have a completely messed up visual experience. Their unified visual field should be warped, stretched, maybe fragmented, like looking through a funhouse mirror.
But what do they actually report?
Amazingly, the sources state they report no significant distortion in their unified visual field. Their perception of space remains largely intact, even though the physical substrate, the brain tissue, is stretched and deformed.
So the physical distance between the processing neurons doesn't matter for the final conscious picture.
It seems not to. The binding mechanism is somehow distance independent within the brain.
Okay, let's recap. We've ruled out brain-wide quantum superposition, ruled out entanglement, ruled out a single convergence point because we can't find one and it would be too slow anyway, ruled out broadcast theories because of privacy and the Hogan twins, and ruled out distance dependence because of hydrocephalus.
Pretty much, yeah. Every attempt to explain conscious unity using conventional local material mechanisms operating at or below the speed of light seems to fail when confronted with the evidence. Science was painted into a corner.
A corner where the only way out seems to be something non-local and faster than light? Which brings us back to Einstein. How can consciousness possibly escape the universe's ultimate speed limit?
This really is the heart of the argument, the breakthrough moment. It feels like heresy, like rewriting physics. But the claim is more subtle. Consciousness doesn't break the rules. It finds an edge case where the rules don't apply.
Okay, let's tread carefully here. Einstein's special relativity. The second postulate is the famous one, right?
Yeah.
The speed of light.
Exactly. It states that the speed of light in a vacuum clearly is constant for all observers in inertial frames of reference. And crucially, nothing with mass or energy can be accelerated to or beyond spacetime.
Right. It's the universal speed limit for anything physical moving through spacetime.
That's the key phrase, moving through spacetime and inertial frames of reference. What does it mean to have a frame of reference in relativity?
It means you have a location in space, a velocity, right? You're an object within the system.
Precisely. And to be an object within that system, to interact with gravity and electromagnetism, to be subject to the Lorentz transformations that dictate how time slows down and mass increases as you approach $2, you need to possess mass and/or energy. The whole framework applies to things with physical properties traveling through space.
Okay. So where's the escape hatch for consciousness?
It comes directly from what we just established. If the lesion studies show the conscious observer cannot be located at a single point in space,
And the timing problems show it can't be something traveling through the brain's network.
then the unavoidable conclusion, according to this thesis, is that the conscious observer does not occupy a frame of reference in space in the way required by special relativity. It's non-spatial in that specific context.
Wait, if it doesn't occupy a spatial frame of reference?
Then the second postulate, the law governing the speed of things moving through space, simply has no jurisdiction over it. The speed limit doesn't apply because the observer isn't playing on that field. It's not an object in space subject to that constraint.
So it can operate FTL without violating physics, because physics, specifically that part of relativity, only applies to things within space-time.
That's the core of the loophole. It's not breaking the law. It's finding a condition where the law isn't applicable. And this non-spatial FTL nature is exactly what's needed to solve the binding problem.
How does it solve it?
If the observer isn't bound by spatial location or the speed of light delay, it can access the information from the left hemisphere and the right hemisphere instantaneously. It collapses the simultaneity problem. The unity is possible because the observer exists, in a sense, outside the spatial separations and temporal delays of the physical brain.
Mind-blowing. Okay, but hang on. Doesn't saying it's non-spatial sound a lot like, well, dualism, like saying there's a non-physical mind or soul separate from the brain? Most neuroscientists hate that idea.
That's a really important point, and the sources are careful here. They argue this isn't traditional substance dualism. They're not positing a ghost in the machine. The FTL observer is defined very specifically as non-energy information.
Okay, unpack non-energy information.
It means consciousness is the pattern, the computation, the informational state itself. It's correlated with the brain's physical activity generated by it, but it isn't the physical stuff itself. It has no mass, no energy. Think of it like software versus hardware. The software information runs on the hardware brain, but isn't made of the hardware's components in an energetic sense.
So it's tied to the physical, but distinct from it in terms of energy and location. That's how it avoids the soul problem.
That's the argument, yes. It keeps it grounded in the brain's processing, but defines the emergent conscious experience in a way that allows for this FTL property based on its non-energetic nature.
That clarification is huge. Okay, but there's another big physics problem with FTL, causality. Going faster than light usually means you can send signals back in time, create paradoxes, all that messy stuff.
Right. The potential for causality violations is the immediate red flag for any FTL claim.
So how does this theory avoid breaking causality? If consciousness is FTL, why can't I use it to, I don't know, send lottery numbers back to my past self?
The loophole protects itself with the definition, non-energy information.
Ah, the non-energy part again. How does that help?
All the physics scenarios where FTL travel leads to causality violations like tachyons or wormholes involve objects or signals that carry energy. To send a signal, to cause an effect, to change something in the past, you need to transfer energy or perform work.
And if the conscious observer is purely non-energy information?
It lacks the ability to perform work. It can't exert a physical force. It can't transfer energy. It's entirely passive in the physical realm.
It's like a perfect instantaneous reader of the brain's state, but it can't write anything back. It can't influence the physical world.
Exactly. It experiences the unified information FTL, but because it has no energy, it cannot interact back through space-time to cause paradoxes. It observes the physical realm, but doesn't energetically participate in it.
So we have two realms, kind of, the physical world of energy, mass, and light speed, and this conscious realm of non-energy information and instantaneity. They're linked, but operate under different rules.
That's a good way to put it. Correlated, but distinct in their fundamental properties. Consciousness observes the physical computation instantly without being constrained by its energy-based laws.
Okay, wow. This is a lot to take in. If you, listening right now, are feeling like your understanding of reality just got flipped upside down, you are definitely not alone. This stuff is genuinely mind-bending. We're about to get into what consciousness actually is, according to this model, and the implications are huge.
They really are.
And look, if you're finding this deep dive fascinating, if it's sparking questions you've never considered, please do us a huge favor. Hit that like button, subscribe to the channel so you don't miss future explorations like this.
Yeah, it really helps us keep digging into these complex topics.
And if you want even more, our detailed notes, the source materials, maybe some behind-the-scenes discussions on how we piece this stuff together, consider joining our membership community. Your support genuinely makes these deep dives possible.
It absolutely does.
Yeah.
Okay, so we've established consciousness as potentially FTL, non-energy information that escapes Einstein's speed limit via loophole and observes passively without breaking causality. Where do we go from here?
Well, if it's non-energy information, the next obvious question is, what kind of information? What is the actual mechanism producing this instantaneous, unified experience? What is consciousness?
Right. The FTL discovery wasn't the end goal. It was the key that unlocked the door. It removed the biggest obstacle, the speed limit problem that had previously made one particular theory of consciousness seem impossible.
And that theory is?
Well, first, let's anchor ourselves again. The observer is non-energy information. This is maybe the first compelling, evidence-based argument coming out of neuroscience suggesting that you, the experiencing self, are fundamentally something more than just the physical particles of your brain.
More than just the wetware, but not a soul, rather. The pattern.
Exactly. A non-material informational pattern, correlated with brain activity, but distinct. And this non-material FTL nature makes the computational theory of consciousness finally viable.
Consciousness is computation. The idea that the brain is like a computer and consciousness is the software, or maybe the output on the screen.
Something like that. Previously, this idea struggled because if the observer, the reader of the computation, was bound by light speed, it couldn't access all the distributed computational results simultaneously. Remember the 587 millisecond delay?
Yeah, that killed the idea of a local reader.
But if the observer has FTL access, because it's non-energy information, suddenly it can instantly read the results of computations happening all over the brain. The timing problem vanishes.
So FTL enables computation as the mechanism. Consciousness isn't just correlated with computation, it is the result of a specific kind of computation.
Precisely. Consciousness is argued to be produced by what the sources call non-trivial computations. It's not just any calculation, but a specific complex type of information processing.
Okay, non-trivial computation. That's a bit vague. How do we know computation is the key rather than, say, some specific chemical reaction or brain structure?
This is where those amazing clinical case studies come back in. They act like perfect experiments to isolate computation as the crucial factor. Hashtag #BATTAB, consciousness as computation, the mechanism revealed.
All right, let's bring back the Hogan twins. We know they have separate consciousnesses despite the thalamic bridge. How does this point to computation?
Think about what's shared and what's separate. They share physical brain tissue, a biological connection. If consciousness arose directly from the biological substance or a field generated by it, they should be merged.
But they're not.
Right. What they don't fully share is the complete set of neural circuits and computations. They have two distinct patterns of information processing running, albeit on partially shared hardware. The existence of two separate FTL observers reading two distinct computational streams, despite the physical link, strongly suggests consciousness is tied to the computational process, not just the underlying biology.
The software, not just the shared server rack. Okay. What about the hydrocephalus patient, the one with the stretched out brain but normal vision?
This case highlights the difference between the physical substrate and the informational output. The physical brain is drastically deformed. Neuron A might now be much farther from neuron B than usual. The wires are stretched.
If consciousness depended on the physical proximity or the strength of local fields, the visual experience should be totally distorted.
But it's not. The patient reports a stable, unified visual field. What does that tell us? It suggests the conscious experience depends on the integrity of the computation itself, the stability of the algorithm processing the visual data, not the physical distances between the processing units.
The software runs correctly even if the hardware is warped.
That's the implication.
Yeah.
The computational relationships are maintained, and that's what matters for the conscious output, not the physical geometry. It's incredibly resilient.
Wow. Okay, that's compelling. But isn't it still possible that some specific biochemical process is the key and computation is just how it happens? How do we really separate computation from biology?
For that, we need patient GY. the blindsight case. This one, I think, really nails the computational aspect.
Remind us about GY, missing visual cortex, blind in one field.
Right. Missing most of V1, the primary visual cortex, on one side. Clinically blind in the opposite visual field. Now, V5 is another visual area involved in motion. If you use TMS, magnetic simulation, on V5, in his good hemisphere, he sees a flash of light, a phosphene. Normal.
And if you stimulate V5 on the damaged side, where V1 is missing...
Nothing. He remains blind in that field, consistent with the brain damage.
Okay, seems straightforward. Where's the computational twist?
The twist comes when they stimulated V5 on both sides simultaneously. Bilateral stimulation.
What happened then?
Phosphenes appeared in both visual fields, including the supposedly blind field.
Wait, what? The same neurons in V5 on the damaged side, which did nothing with unilateral stimulation, suddenly produced a conscious experience when stimulated as part of a larger bilateral pattern.
Exactly. The physical neurons were identical in both conditions. Same biochemistry, same location. The only thing that changed was the overall computational context, the pattern of input they were receiving as part of a network-wide stimulation.
So consciousness literally switched on and off for those neurons based purely on the computation they were participating in, not their inherent biological state.
That's the stunning conclusion. It's participation in the necessary, non-trivial computation that determines if a neuron's activity contributes to consciousness. It's algorithmic, not just biochemical.
And wasn't there something about the phosphene itself?
Oh, yeah, the kicker. The phosphene that appeared in GY's blind field, he reported it as the wrong color.
A glitch. A computational error.
A beautiful little piece of evidence suggesting it wasn't just restoring normal function, but triggering a conscious output via a specific, perhaps slightly flawed, computational process.
This computational view seems consistent with other things too, doesn't it? Like the difference between the cortex and the cerebellum.
Absolutely. The cerebral cortex is the seat of consciousness. The cerebellum handles complex motor control, but isn't directly conscious. Yet, biochemically and genetically, they're surprisingly similar. Minor gene expression differences.
So if it was just about specific molecules, you'd expect a bigger difference.
Right. The major difference is their computational architecture. The way they're wired and process information is fundamentally different. That suggests the architecture, the computation, is the key differentiator for consciousness.
And things like general anesthesia.
They work primarily by disrupting neural communication, by interfering with the complex computational dynamics across large-scale brain networks. They suppress the necessary computations. Psychedelics, conversely, might increase or alter those computations, leading to different conscious states. It all points back to information processing.
So the picture emerging is the FTL observer, this non-energy information, instantly reads the output of complex, non-trivial computations running on the brain's hardware. That computational output is our conscious reality.
That's the synthesis presented in the sources, yes. And it's a framework that doesn't just explain binding. It has profound implications for some of the oldest philosophical questions we have.
Like free will and the nature of reality itself.
Exactly, the ultimate implications.
Okay, let's go back to that core definition one more time because it seems critical here. The conscious observer is non-energy information.
Right. No energy means no ability to perform work, no ability to exert physical force.
So if the you that is experiencing consciousness, the observer, has no energy,
then it cannot physically cause anything to happen in the brain. It can't intervene in the chain of electrochemical events. It can't nudge a neuron one way or another.
It's purely passive, an audience member watching the deterministic physical processes unfold.
That's the implication. The observer reads the computational state, FTL, experiencing it as subjective reality, but it doesn't direct the computation.
So what does this mean for free will? The feeling that I consciously decide to lift my hand?
It strongly suggests that the feeling of conscious control, the sense that I initiated the action, might be, well, an illusion. The decision, the initiation of the action, arises from the deterministic or perhaps random quantum processes in the brain's computations.
And the FTL observer just experiences the result, perhaps slightly after the fact, and creates a narrative of having been in charge.
That's the line of reasoning this theory supports. It aligns with evidence from neuroscience, like Libet's experiments showing brain activity precedes conscious awareness of deciding, or conditions like
alien hand syndrome, where a person's hand acts purposefully, but they feel no conscious control over it.
Exactly. or split-brain patients, where one hemisphere initiates an action and the other hemisphere, connected to language, instantly confabulates, just makes up a plausible reason for why they did it, even though it had no input into the decision.
The conscious observer as the ultimate post-hoc storyteller, reading the script written by the physical brain.
It's a challenging view, but it flows directly from the non-energy, passive nature required for the FTL loophole. It doesn't leave much room for traditional notions of top-down conscious causation. The observer reads, it doesn't write.
Chilling. Okay, so if we're passive observers of a computation, what does that say about the reality we're observing?
Well, if your experience is the output of a computation based on sensory data processed by your brain, and you're just passively observing that output, then fundamentally your conscious reality is a simulation.
Not simulation in the sense of, are we living in the matrix necessarily, but simulation in the sense that my direct experience isn't the raw world itself, but my brain's constructed model of the world.
Precisely. You never experience external reality directly. You only ever experience your brain's interpretation, its best guess, its internal model, generated by those non-trivial computations.
And we see evidence of this construction process all the time, don't we?
Constantly. Think about your visual blind spot. You have a physical hole in your retina where the optic nerve leaves, but you don't see a black hole in your vision, do you?
No. My brain just paints over it, fills it in with whatever it expects should be there.
It actively constructs a seamless reality where information is missing. Or color constancy, you perceive an apple as red, whether it's in bright sunlight or shadow, even though the actual wavelengths hitting your eye change dramatically. Your brain adjusts the input to maintain a stable perception.
Or even seeing the color yellow on a screen like this one. Most screens don't actually emit yellow light.
Right, it's just mixing red and green light. The yellow you experience exists only inside your head, a creation of your visual system's computation based on those inputs.
Yeah.
Your reality is manufactured.
So let's tie it all together. The observer is FTL, non-energy information. It passively reads the output of the brain's computations. That output is an internal simulation, our subjective reality.
That's the picture. Which leads us to the final, really unsettling, provocative thought. If the conscious observer is non-spatial, non-energetic, and its entire experience is this instantaneous, internally generated simulation based on computation, is the external physical realm even strictly necessary for the experience to exist?
Whoa. Could the simulation run? Without the world it's supposed to be simulating.
From your perspective, trapped inside the simulation generated by your own brain's computations, relying solely on that FTL observer reading that internal data, how would you ever know?
Solipsism, the ultimate uncertainty. I can only be sure of my own consciousness, my own simulation. Wow.
So let's just quickly recap the journey we took today. We started with the binding problem, the mystery of instantaneous conscious unity.
We saw how conventional explanations involving quantum mechanics, specific locations, or light speed travel within the brain all failed to account for the evidence.
This forced science towards a radical conclusion. The conscious observer must operate faster than light.
A feat made possible by a loophole in special relativity, applicable only because consciousness is defined as non-energy information, which doesn't occupy a frame of reference in space.
This FTL capability, in turn, made the computational theory of consciousness viable. The evidence from the Hogan twins, hydrocephalus patients, and patient GY strongly suggests our reality is the output of complex, non-trivial computations, independent of mere physical proximity.
And this computational, simulated view of reality, observed passively by a non-energetic entity, challenges fundamental ideas about free will and leaves us questioning the ultimate nature of the world versus our perception of it.
The big takeaway. The secret to consciousness, to your subjective reality, might not lie in specific particles or chemicals, but in the structure and dynamics of information processing itself, in the architecture of computation.
Which leaves us with the final, tantalizing question to ponder. If computation is the key, what specific kind of non-trivial computation is it? What precise algorithmic structure is necessary to generate the richness, the unity, the feeling of being you? What's the unique code running inside our skulls?
Figuring that out. Well, that's the quest for the next generation of scientists exploring the boundary between physics, information, and the mind.
We hope this deep dive gave you a lot to think about. Thanks for joining us.
We'll see you on the next deep dive.